Good afternoon to you all. First of all, thanks for the organizing committee for allowing me to present during this conference. It's a once in a while opportunity. I'm Filex Otieno, finalist student at Kabarak University B.Pharm program. I'm going to present on virtual screening for chemical analogues similar to phytochemicals that inhibit aldose reductase in the development of diabetic microvascular complications. Background. So diabetes mellitus is a chronic metabolic disease that once diagnosed has a poor prognosis. It is the 9th leading cause of death globally and one of the major reasons why there has been noted increase in deaths amongst male. Chronic diabetes mellitus is usually associated with the development of medical emergencies, the likes of diabetic ketoacidosis and ketotic hyperosmolar state, progressive microvascular diseases, complications like retinopathy, nephropathy, neuropathy, and macrovascular complications, which include hypertension. Amongst all these, the complications and the emergencies, more on the complications, the common pathways that lead to these complications are formation of advanced glycated end products, low-grade inflammation, induction of oxidative stress, and the sorbitol pathway. So the AGs are just glucose being covalently bonded to proteins within the body, disrupting their functions. The low-grade inflammation is a result of immune response, similar to induction of oxidative stress. So majorly this study was focusing on the sorbitol pathway, which is not a main contributory factor, but a very important one, since the substrate required is glucose, and in diabetes mellitus we have an excess of it. So in the diabetic complications, the pathological hallmark usually surrounds the vascular system, both in neuropathy, nephropathy, and retinopathy. And we know microvessels control blood pressure, while macro function as transport vessels. In diabetic patients, excessive glucose resulting from the hyperglycemia causes thickening of the capillary basement membrane and an increase in protein synthesis within the extracellular matrix of microvessels. So this, together with the glycated end products, the ongoing inflammation causes dysfunction of the microvessels, and this enables microvascular complications to ensue. Aldose reductase, as I had earlier said, this study is going to focus more on the sorbitol pathway. In that pathway is a two-step pathway involving two enzymes, aldose reductase and sorbitol dehydrogenase. So aldose reductase is an unspecific enzyme catalyzing the conversion of any sugar within the body to its alcohol form. Normally in an unhealthy individual, the enzyme has a very low affinity for glucose, but that changes in hyperglycemic conditions where we have increased amount of glucose concentration. This enzyme is found localized in the kidneys, Schwann cells in peripheral nerves, pancreas and cortical cells, and the epithelia in the lens. What you can notice is that these organs are majorly, they receive their glucose in an insulin-independent way, more or less. So meaning they don't require insulin for regulation of glucose intake. So in a state of hyperglycemia, there's a lot of glucose there taking to the intracellular compartment. Nearly 600 plant species have been shown to have antidiabetic properties, majorly from ethnobotanical studies, and extracts from these plants are phytochemical compounds that influence the glucose metabolic pathways. So specific phytochemicals, especially flavonoids such as quercetin, mangiferin, and luteolin, have potent aldose reductase inhibitory effect. So this study aimed at analyzing analogues of such flavonoids. Focus was on quercetin and luteolin to see if we can get compounds that we can develop into drugs that can be used to delay onset and progression of microvascular complications. So as earlier stated, it's the sorbitol or polyol pathway is a two-step pathway where glucose is first converted to sorbitol, the alcohol form, by the enzyme aldose reductase. The intermediate byproduct is then converted to fructose, which sort of limits the end product, that fructose from getting out of the cells. So at the end of it, you have fructose and a mild of sorbitol and glucose accumulating within the cells, which are osmotically active. So in the end product, they cause swelling and development of these complications: neuropathy, nephropathy, and retinopathy. So the methodology, this was a computational approach. So an in silico study design was utilized. First, we identified the plants and their phytochemicals from literature review. And then we validated whether such phytochemicals do bind to aldose reductase, since it's the rate limiting enzyme. Two phytochemicals, luteolin and quercetin, which are all flavonoids, were selected for this study. Sulindac is an NSA drug, but we chose to use it here because we chose to use it here as our comparator, one of the standards. So we are going to look for analogs for luteolin and quercetin, and we compare the docking scores of those analogs to luteolin, quercetin, and also sulindac. So structure and canonical smiles of luteolin and quercetin are obtained from PubChem website, and the similar compounds were extracted using Swiss Similarity, which is an online tool. Swiss Similarity was used to scan databases. So in this case, we chose Zinc database, which contains millions of chemical structures. So we are looking for structures similar to luteolin and quercetin. And 20 chemical analogs for each phytochemical compound was selected. So that is the top 20 with the most that were most similar to each of the two selected phytochemical compound. Our receptor, that is the enzyme aldose reductase, was obtained from RCSP, Protein Data Bank, which is also another online database that contains structure of various proteins within the body. And we standardize the enzyme aldose reductase using Chimera. Chimera is now an application installed. And what we mean by standardizing, we remove any residue or any non-standard amino acid attached to that enzyme. Autodocvina, it's also another software. You embed it within Chimera such that when you are running the Autodocvina, you run it simultaneously with the Chimera to check the docking scores for the compounds. Visualization of interaction between the ligand, that is the analogs, and the protein, in this case aldose reductase, was done using BioVia Discovery Studio, which is also another program. CSADME is a website, an online website here, and was used to assess the pharmacokinetic profile in terms of GI, absorption, enzyme inhibition, blood-brain barrier penetration, among others, of each of the analogues. We also did toxicological analysis using Protox server, which is an online website to determine the LD50 for the 20 analogues or 40 analogues. And the result, so our phytochemical we had to luteolin and quercetin. The predicted probability here represents similarity of, the ability of these compounds to bind to aldose reductase, and it was 100% for both the two phytochemicals selected. For the enzyme aldose reductase, you can see the 3D structure. It's not a very big complex protein. Then the hydrophobic surface where the compounds were binding. So the bluer portion represents a more hydrophilic side of the receptor, while towards the red-orange, it's more hydrophobic. White is an intermediate between the two. For Sulindac, similar, so we can see the drug Sulindac, the NSAID binding to that pocket. And when we look at the ligand receptor interaction, so majorly interactions occur within the indene ring. This is the indene ring here. Yeah, a benzene bonded to that substituent, yeah. Just talk about the interactions later. So similar to here, we had quercetin, the structure of quercetin. We had the structure of luteolin, and in both we can see we have a chromine ring. So this is the chromine ring, similar to here. Different is now the substitution on either, but both are flavonoids. For quercetin and luteolin, both did fit well in the hydrophobic binding site pocket, as you can visualize here. And the interactions shall talk about them later. The zinc compounds, these are now the best analogues in terms of, after the final analysis, that were likely to bind, to the hydrophobic pocket. So for quercetin, we had this compound, and you can see it's fitting quite well in the hydrophobic pocket. For luteolin, we had this other zinc compound, and you can see it's fitting also quite well in the compound. This represents now the pharmacokinetic analysis together with the toxicological analysis. So we had the Sulindac, which was our comparator. You can see the docking score. That is the strength, the binding strength to aldose reductase was at negative 9.6. So usually the program, the more negative the docking score, the higher the binding strength that is predicted. First, for Sulindac, which was our comparator, the docking score was at negative 9.6. It had a low LD50 to 64 milligrams per kilogram. And nevertheless, it had a high GI absorption. It was not a substrate of pig glycoprotein and did not permeate the blood-brain barrier. But it did inhibit cytochrome P enzyme 2C19, 2C9, and 3A4. So these are potential drug-drug interactions that we might encounter. For luteolin, we can see it had a higher docking score than Sulindac, similar to quercetin at negative 9.7. But when it comes to LD50, luteolin had a value of 39 3,919 milligrams per kilogram compared to that of quercetin, which was at 159 milligrams per kilogram. So generally, luteolin, it's more safer than quercetin when taken. So in terms of GI absorption, luteolin and quercetin both had similar, the results were more or less similar. They had a high GI absorption. They were not a substrate for peak glycoprotein, and they did not permeate the blood-brain barrier. All were inhibitors of CYP1A2 and CYP2D6 and CYP3A4. So upon analysis, for luteolin, we had 20 chemical analogues we chose to analyze, similar for quercetin. But here we are saying for luteolin, we have 6 zinc compounds which have a binding strength or a docking score more negative than the parent phytochemical and the comparator. And the highest for luteolin was at negative 10.5 with a very large LD 50. For quercetin, the best compounds had a very large also docking score at negative 10.6, but looking at the LD50, they were a bit low. So we could, the zinc compound number 3 is the one we could select since the LD50 was at 4,000 milligrams per kilogram. But these ones are a bit lower and could pose toxicological problems. So general discussion is what I've talked about, but to add on to that, this structure of sulindac, if you can look at the structure of sulindac, we have a thiocarbonyl moiety that is substituted to a benzene group. And based on studies, that is one of the structural activity relationship that is required for a potent inhibitor of aldose reductase, the enzyme. So in sulindac, we have a thiocarbonyl moiety next to a benzene group. In luteolin and quercetin, we have this carbonyl group as part of the chromine ring. This is a chromine ring. So here it is. So generally, you need to have a primary lipophilic moiety, often an aromatic ring, and a thiocarbonyl or carbonyl group that is located at the 2.8 to 3.8 angstroms from the center of the primary group. That is just what I've explained. And acetyl salicylic acid and sulindac usually conform to such requirements. However, we usually need higher concentrations to inhibit, higher concentrations of both acetyl salicylic acid and sulindac to inhibit the enzyme. And these two drugs, the NSAID and NSAIDs at higher concentration pose other adverse reactions to the body. And that's why the flavonoids are more better. Flavonoids, we only need them at very minute concentrations. So addition of a second lipophilic group has been shown to increase inhibitory activity as seen in compounds such as quercetin, even at micromolar concentrations. So the second lipophilic group represents this substituted benzene group at luteolin and quercetin. It's just a benzene with hydroxyl groups. So that addition of that group increases inhibitory activity, and also for these two drugs makes the requirement to be, means that we need to take them at very low concentrations, not such high, so as to inhibit the enzymes. So in general, luteolin and quercetin are predicted to have a slightly stronger binding affinity for aldose reductase enzyme than sulindac. 8 out of the 20 analogues of luteolin are docking below both Sulindac and parent phytochemical with zinc compound. So that was the compound with the highest binding strength compared to luteolin, while for quercetin we had 3, but only one was a favorable candidate due to the LD50 index. That is zinc compound 57845. Yeah. So this is just what I was just explaining in terms of chemistry, the thiocarbonyl moiety in Sulindac. So if we look critically here, you can see the thiocarbonyl moiety interacts with valine amino acid and isoleucine, while the benzene ring interacts with valine, but at different positions, and alanine at position 155. While the indene ring, this was the indene ring, interacts with these other ones. So comparatively, if you look at quercetin, we can see the same valine interacts with the carbonyl moiety at this point, this bond here, but not the alanine. We have newer amino acids, leucine and methionine, and another valine at another position. So generally, this was similar to luteolin, as you can see. The carbonyl is here, it's interacting with methionine at position 144, valine at position 148, and leucine at position 147 of the enzyme. So in generally, this shows we don't have a tight binding spot for inhibition of that enzyme, but rather peptide amino acids running between the 100 peptide amino acids between the 100th position to the 150th position could be bounded to cause an inhibition of that enzyme. Yeah. On pharmacokinetic profile, we have discussed most compounds did not inhibit, did not violate Lipinski rule of 5, which is one of the requirements for drug discovery. Had a high GI absorption, meaning we could formulate them as oral drugs. Neither crossed the blood-brain barrier nor was a substrate of pig glycoprotein. So usually pig glycoprotein functions to efflux drugs from the body into luminal surfaces such as the intestine. So it decreases absorptions, but in this case, it was not a substrate, which is a good thing. Both phytochemicals were inhibitors of cytochrome 1A2, 2D6, and 3A4. Potentially, this could be drug-drug interactions, but with further modifications, we could get better compounds. So on toxicological analysis, luteolin was predicted to be safer, having an LD50 of 19 milligrams per kilogram. Quercetin and Sulindac had an LD50 of 159 milligrams per kilogram and 264 milligrams per kilogram respectively, which are lower and shows that these compounds are more toxic and could pose toxic problems to the body. Two luteolin analogues fell under class. So for luteolin, we had 8 classes that had a better binding affinity than both the parent phytochemical and the comparator. Out of those 2 were under class 3, while the rest are under class 5 with similar predicted LD50 values. So usually class 5 is much better than class 3. 5 quercetin analogues out of the 14 had an LD50 of 159, which is quite low, while the another 5 had an LD50 of 3919, which is quite high. Then 2 of the remaining analogues had an LD50 of 4,000 milligrams per kilogram, while the other 2 had an LD50 of 5,000. So the higher the LD50, the more safer the compound is predicted to be. So in conclusion, luteolin and quercetin had better docking scores, thus higher binding strength compared to sulindac. 8 out of the 20 luteolin analogues had docking scores more negative than the parent phytochemical, meaning they had better binding strength. Similarly, 14 out of the 20 quercetin analogues had docking scores more negative than parent phytochemical compounds. So out of the 8 and out of the 14 analogues, 1 luteolin analog and 3 quercetin analogues had the strongest predicted value at -10.5 and -10.6 respectively. Both phytochemicals had similar pharmacokinetic profile, and all obeyed Lipinski rule, having high GI absorption, and neither did they cross the blood-brain barrier, or were they in substrates of pig glycoprotein. Most analogues of luteolin were generally safer, while quercetin analogues having wider range of LD50 compared to luteolin. So in generally, we found 8 luteolin compounds and 14 quercetin compounds that could be further analyzed as potential hit compounds for drug discovery. Yeah, and I'm done. In case of any question, you can just ask or send my email.